Hello, we are here today for a presentation of another module that T-Flex has inside this suite of solutions. And today the presentation is for T-Flex Dynamics. This is a special environment and we usually say that this is a multi-body dynamics simulation software. Okay. This is a module that runs on top of T-FlexCAD, so you need to have T-FlexCAD installed, and then you can use an express installation built in T-FlexCAD or install the full module that is T-Flex Dynamics. I will open a file that I've prepared previously to run a very easy and I hope very clear simulation that allow you to understand what can we do and the concept of working with this. So I will open a file. I have this very simple module, and this is something that I've created inside T-FlexCAD, and I will run some simulation with the dynamics module. Before we see the module and the concept and how to work with it, I'd like to speak a little more about this dynamics module, because this is intended for a quantity and the quality analysis of mechanics, kinematics, and dynamics. We can find this in this group analysis, and when we start a new calculation, we go to this new study, and then we have two types of studies. This v.15 study, which in fact it is a finite element analysis, or this dynamics below, dynamics motion study. And when we enter, if we don't have the full module installed, we'll have only the express installation, which does not cover all the commands and all the possibilities. This express module is free, okay? And the other one, it is paid. So this dynamics module is focused on analysis of mechanical systems subjected to external and internal forces, mass inertial characteristics of individual parts of the system, and interaction of mechanical system components. We can use this, for example, to simulate the movement of mechanisms with complex relations when designing new machinery, new equipment, to check jamming, to simulate false interactions of bodies at collisions. This is integrated in T-FlexCAD. They both use common principles, common user interface elements, and unified geometry models. So you can use also the same elements that you create with the CAD, being these having these integrated, so you can use everything, changing only from a menu to another one. This dynamic analysis is capable of solving several things, like, for example, the analysis of motion, trajectory, velocity, and acceleration of any point of a component in a mechanical system under applied forces. We can analyze also performance times of these same mechanical systems, like the time to reach a target point, vibrations to settle, etc., or analyze forces building up in components of a mechanical system during motion, reaction force that supports joints, whatever. Okay, we have a lot of possibilities. There are some rules, okay, and some common elements in all the studies, but let us briefly describe how to use this. So first step is to go into this option here and create a new study. We can have several studies inside, so dynamic motion solution. we have these two possibilities: dynamic motion analysis, which is the paid module, which I have installed, or the express one, which is the reduced functions we have only inside the standard T-Flex CAD installation. So I will leave this dynamic one. I will choose the solids to analyze. So contact analysis, I can choose from off all solids or choose manually which solids are to be analyzed. In this particular case, what I have, it is a table or a box where I have two spheres, and I've applied characteristics to each one of the materials. This one is a metal container. This one is a sphere made out of rubber, and this is of granite. So they have different densities and different characteristics that will be applied when we study this system. So contact analysis, all solids, and we can have, or we can consider these coefficients for frictions and so on. So we can change this, consider these factors, change the values or not. I will leave this, it's not very important for this purpose now. And I can define also some basic definition about the time to analyze. I can say I don't want so long, I want to analyze this in 15 seconds, for example. Not 50 frames per second, but for example 20 frames per second, and okay, and do it. I can now say I want to apply a force, and in these initial things we can apply a force, a rotation, a torque, initial velocity, or spring. Each one of these things have different characteristics, but simply I will apply a force, and a force I will say to this body. So I will apply a force that will send this sphere against the other one. So in this body, on the point I will say the center of the sphere, and on the direction I will say this direction here, okay? And the value of the force, so kilos, I would say 2 kilos, and that's it. Now I want to measure things, so I will apply a different element called a sensor. I can have multiple sensors, but I will say a sensor, and I want to study the behavior of this sphere here. So I will say, and I can apply, I can visualize values of several things like the trajectory, linear velocities, angular velocity, accelerations, whatever, okay? So I want to apply this sensor in one point, and I can study, for example, the trajectory. So I want to study this element here, and I can select a point which can be also the center, and done, okay? And I can now show the result of this. For example, I can study the y direction or multiple things, okay? Y coordinate applied to this sensor. And I need still one more thing, which is to go, I'm not sure if I can do it, probably not. Right click with my body one, which is the plate, and say I want to fix this component, okay? And now I want to do the study. Okay, I have my graphic, which I can move back, okay? I have the values here, and I think all it is settled, so just record. Okay, and my balls are around here, so I will leave them. Let us see the graphic. So you see, okay, in terms of time, we have these plotted values here, and we can move with the slider to see what happened to the balls, and we can have the values or the forces or whatever we want to study here. Okay, we can change this a little because I can draw something. Let us try to make this, create a pin, for example. Let us, okay, something like this. Okay, and let us do the extrusion out of this guy here. Okay. And make a boolean, so to join this one to this one. Okay, and let us do the fixing again, and we can make a new study, or let us create a new study, so we can have multiple studies, and we can run the same simulation. So contact all solids. Okay, friction, let us leave this. Let us say now 10 seconds. There is no need to analysis 2. So okay, we can create again a force to this element here, apply to the point and the direction. We can, okay, now 1 kilo. That's it. Let us create also a sensor now for the linear velocity, trajectory and velocity both, to also to a point to this guy, this point, and do it and show the results. Sensor 2, so I would say velocity in y, x, and coordinates, a lot of those. Okay, and I can go to study, and we have a lot of graphics around here now. We can, okay, let us try to put this a little smaller, and let us shorten this guy here and run it. Okay, and we get this analysis, which we can stop or also record a video file or export animation, whatever, and we can run. Okay, we have this behavior. Okay, and we can see all of these graphics. We can do a lot of we can work around these graphics. Okay, we can set these options, and we can study what is happening here. Besides all of these things, we can have also the possibility to apply mates to the elements, and you know the meaning of mates. Mates, it is something that allow you to restrict the freedom of the elements. So we can study these behaviors of these mechanical systems, but we can, with these mates, restrict what we want to obtain. Okay, not free motion as I'm allowing here. With the balls can run freely around this plate, but in some mechanical systems we may need to have this mate. So this is a new possibility and a very interesting element also to include in these studies. But basically this is the concept to work with this dynamic module. This is a very simple example. the idea of this general presentation of this dynamic module is to show you briefly how to create elements and how to create a study. We are still showing this in this 15 version, and the 16 version was just released this past week. So we will try not far from now to include examples of studies of more complex mechanisms and the different possibilities to work with this module, because we have the possibility to create joints, really complex system, and to extract value information about the CADS module that it's important for the designer or for engineer to take decisions. So again, a general presentation, video and concepts. Any question or any help you may need using this module, you can contact us through the usual ways that you know already. We are here to give you all the support needed, but for now I think it will introduce you in this new module, and with the future videos of examples, I hope to cover a lot of possibilities and to give you the material to support you in the use of this T-Flex suite of solutions.